Okay, let's look at another example. Before we do that, let's go back to the purpose of Lewis diagrams. So the idea is to show where all the electrons are in the molecules, and there are a series of 5 steps that are very important. First of all, and often actually this one gets missed by mistake, the number of valence electrons in the outer shell has to be shown, right? That's really important. So that means we have to count them up. All right, next, as you saw with methane, we put the symbols in their approximate positions. Put a pair of electrons where each bond is. So each bond, covalent bond, that means. Okay, then sometimes we need to put electrons around the other atoms because, as you'll see in a minute, there's too many electrons to just have them in the bond locations. And then step 5, sometimes we actually have to move electron pairs around. So we count the electrons around each atom. If an atom does not have a full outer shell, or all of its valence electron pairs, then we've got to move them from a non-bonding space to a bonding space. What the heck? Well, we'd better look at an example to figure out what that all means. So what we'll do here is to use this example here, carbon dioxide. So first of all, we need to look at the number of electrons. Carbon, as we saw before, has 4 in its outside shell. Oxygen is in group 16 of the periodic table, so it's got 6 electrons. There's 2 of them, there's 2 oxygens. Add those all together and we end up with 16 electrons. So that's what we're dealing with this example. So here goes carbon in the middle. We're going to put carbon in the middle. That's the one which we know needs 4 electrons shared with it as well as its own. So that's going to go in the middle. The oxygens will go around the edge. So I'm going to put one here and one over here. Doesn't really matter where they go. They could have gone up or down there. The next step, if you remember, I've got it up here, but you probably can't read it at that size, is to put the electrons in their bond in the bond. So we'll do one here. So there's the covalent bond between carbon and oxygen. One there, one there. So that's now carbon and oxygen are bonded together. But we've still got, that's only used up 4 electrons. We've got to use up 16. So the next step was to go around the edge, around the outside atoms first. So here we go. We've already got 4. So I'm going to keep going up to 16. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now we can't put any more on. That's as many as we've got. So at this point, let's have a look. Oh, both oxygen atoms have got 8 electrons around them. That's great. Carbon, though, has only got 4. 1, 2, 3, 4. It's only got 4 electrons. It needs to get another 4. So what we do is we're going to take one of these lone pairs, what we call a lone pair here, and we're gonna rub it out from there. We'll see if we can ditch it. There we go. And at the same time, we're going to ditch one over here as well. And we're going to put them back in just here. In fact, like that. So in between the carbon and the oxygen. So instead of putting it on top of the carbon there, I've put it next to the carbon. So this now becomes a double bond. So there's 2 double bonds between the carbon and the oxygen. So that oxygen has 8 electrons around it. This carbon has 8, 2 lots of 4. This oxygen has 8 as well. Another way we can draw that, which is kind of a little bit clearer, is to draw each bond as a line. 1, 2 lines. So that's each line is for 2 electrons. That's one bond. There's another bond. There's the bond there. And we also have to put the electrons around the edge, just like we had before. It's just going to take me a while using this pen, but here we go. We'll go like that for that oxygen, And here we go with this one as well. Okay, and that's the answer. For carbon dioxide, that is the Lewis diagram right there. All right, and it's got double bonds in it. So the Learn Coach tutorial, I thought, didn't quite nail that, and neither did the PowerPoint provided by GZ Science in terms of explaining where all this comes from. So hopefully that makes sense. SO2 is a strange one that you're going to, if you do that one, you'll end up with one single and one double bond. So give that one a go as well. All right.